So, welcome you all to today's LeetCode challenge. This is our day 291. This is problem number 684. The problem name is redundant connection. In this problem, we have given a tree that is an undirected graph that is connected and has initially no cycles present in that. We have a tree with n nodes labeled from 1 to n and within one additional edge is added later on. The added edge has two different vertices chosen from 1 to n and was not an edge that already existed. The graph represented as an array edges of length n where edges of I is equals to a of I comma b of I indicates that there is an undirected edge between a of I to b of I. We have to return the edge that is additionally added later on and that creates the cycle in that undirected graph or a tree. If there are multiple answers possible, so we have to return the last answer that is present in the input array. Let us take the example number 1. We have given a vector of vector, a 2D vector or named edges contains vectors 1 comma 2 1 comma 3 and 2 comma 3. This 1 comma 2 state that there is an edge between 1 comma 2 1 comma 3 and 2 comma 3. So the brute force approach to solve this problem should be if while moving on edges, let us takes the first edge and do a DFS for this edge while removing the 1 comma 2's connection. Let us find out that if there is an cycle found in this or not. Mm, like if we do a DFS from 1, so we have found out a cycle. So 1 comma 2 is a possible answer and this could be our one of the multiple answer present in this 1 comma 3 if we start a DFS from this node we will find out a cycle. So 1 comma 3 is also a possible answer, but as the question states that there could be multiple answers, so we have to return the last answer possible in input array. So now let us take 2 comma 3. If we do a DFS from this, then we can find out a cycle. So this could be our last possible answer for this. And for this approach, the worst case possible should of is big O of v into n, that is 10 to the power 6 at max. So the brute force will work, but we will do this using the concept of disjoint sets. So now let us code first and then we will dry run our code. What is the logic behind this code? Let us first take the size of input vector of vector. Let us zoom this and then we have to initialize our vector of int named dsu, which is of n plus 1 size, that is initialized to -1 initially. Now moving on all edges present, we have to find out the parent of the first edge of 0. Parent of edge of 0. DSU edge of 0. Now we have to find out the parent for edge of 1. What is the possible parent, absolute parent of edge of 1? Now we have to check if this parent of x is equals to parent of y. Then we will find out our answer that the this present edge is an additional edge, and we will simply return that. If this case is not possible, then we have to update our parent of x as y. If there is no answer possibly we have found in this, so we have to return an empty vector containing 0 comma 0, but this line of code is unreachable because we definitely found out an additional edge that is creating an loop. Let us run this code first. Oh, we forgot to add our find which int takes a vector of int as DSU. Let us zoom this. The base condition for this recursive function that if DSU of v is not equals to -1 or equals to -1, then the v is the absolute parent for this node, and if this case is not possible, then we have to update our parent of v by the recursive calls like this. And now let us again run this. This is running fine, and if we submit this, yes, this is absolutely running fine, and this beats 100% of users. So now let first visualize our code, what we are doing here. For example number 1, we have the undirected edges between 1 comma 2, 2 comma 3, and 1 comma 3, and the current size for this is n equals to 3. So we have to initialize our DSU as 3 plus 1 of 4 size, with initialize with -1 and -1 and -1. For this, the input array is like this. The edges are 1 comma 2, then 1 comma 3, and the final edge is the 2 comma 3, like this. So what our function is doing, let us visualize this. For every edge we were fetching every edge. So for first iteration we were fetching this edge, like this edge. Yeah, the parent for parent x for DSU function. Inside the function, the DSU vector is passed by reference, and this one is passed. So what this DSU function will do for us, inside DSU, this v is 1 now. So this will check if DSU of 1 is equals to minus 1, that is minus 1 here. So this will return v as the answer. So in parent of x, this function will return 1, this will return 1, and now again parent of y. So we find out the parent of y. What is the parent of y? We will call the same function DSU with edge of 1, that means with 2 this time. And if we go inside the DSU function, this v is now 2, and this will check if DSU of 2 is equals to minus 1. If DSU of 2 is equals to minus 1, yes, it is minus 1. So this will return v as the answer. So this will return 2 as the answer. So from here 2 is written, and now our if condition is checked. If parent of x is equals to parent of I, so we will check if this returned answer is true or is equal or not. So we found out that 1 is not equals to 2, so this condition is false. So we have to now made the union. We will update our union DSU, and then DSU of parent of x is updated to parent of I, means DSU of 1 is updated as 2, means this could be 2 now, like this is 2 now, and this function, this first edge is now removed, and our iterator goes to the second edge here. This time parent of x will contain the value returned by our find function. DSU, which is updated like this now, and this will give us v1, and p of y means parent of y will now contain the value returned by find function for the input 3. So let us check for one what this find function will return to us. For one, this v is 1, and inside the function we will check if DSU of 1 is equals to minus 1. And let us check if DSU of 1 is equals to minus 1. No, it is not minus 1. So this condition gets false. So we will update our DSU of v with found find DSU of v, means this function is recursively calls itself with DSU of v, means DSU of 1 this time. This is called with DSU of 1 this time. So what is the value for DSU of 1? We found out that this is 2. So now this function call is now this is called like this, DSU for 2, and again the function is called for DSU of 2. This will again check if DSU of 2 is equals to minus 1. DSU of 2 is equals to minus 1. Yes, this condition gets true, and this will return 2 as the answer. So for this one, a 2 gets written, and P of y, the function call will now like this, DSU of 3. So v gets 3, and the function will check if DSU of 3 equals to minus 1. Yes, DSU of 3 is equals to minus 1. So this will return 3 as the answer. So this function call will return 3, and again inside this function, p of x is equals to p of y will check, and as we can see that these are not equal, and this condition gets false, and we will now update our DSU. That is, we have to take union. So update DSU of 2 for 2 3 means we will have to update our DSU of 2 with 3 like this, and now this edge will also be finished. So our iterator move to the next edge. Here again p of x is contains the value returned by the function find with the updated DSU till now, and p of y contains the updated value for 3 in DSU. So when DSU for 2 is called, what will happen? This time this we receive the value 2, and this will check if DSU of 2 equals to minus 1. If DSU of 2 is equals to minus 1, no, this is not minus 1, this is 3. So the condition gets, if condition gets false, and this DSU of 2 is now received the value returned by this recursive function call. So this recursive function calls itself for DSU comma DSU of 2. What is the value of DSU of 2, which is 3. So this time this recursive function calls for 3. So this time we receive the value 3, and again this DSU will check if DSU of 3 equals to minus 1. Yes, DSU of 3 is equals to minus 1. So this will return 3. The recursive function will return 3. So this DSU of 2 will receive 3 as the answer. Here we can see that 3 is already present at this. So this will return 3, and this function DSU will now call for DSU with 3. So now this time we will receive the value 3 and check if DSU of v is equals to minus 1. That means that DSU of 3 is equals to minus 1. we will check that DSU of 3 is equals to minus 1 is true. That means this will return 3 as the answer. So this will return 3. That means this P of y will receive the value 3. And now the condition checked is that parent of x is equals to parent of y. Yes, we found out that parent of x is now parent of y. So we have to return this presented as. Our iterator points to this as, so this could be our final answer. This edge is our final answer. So this DSC function will work like that. I hope you all will clearly understand the concept of this DSU, and by this debugging I will ensure that you will understand this. And thank you so much guys for today's LeetCode video, and keep supporting. Please do like and subscribe to our channel. Thank you so much.